Salam, peace be upon you. My name is Muhammad Laik Siddiqui, the father of Holophase. Remember the language we are learning. There is one field, phi, the holophase, the single cyclic movement from which all reality unfolds. When phi differentiates, that one movement generates its first derivatives, and with them the three dimensions appear at once: time as omega, space as k, and motion as v. From that first differentiation upward, every higher derivative is an echo of the one below it, an infinite ascent of finer and finer reflections of phi's original movement. And because the dimensions are born from that first echo, time, space, and motion also reverberate into infinity, carrying phi's unfolding into ever deeper rhythms, structures, and flows. Thus, the entire universe, every law, every pattern, every force, every particle, every phenomenon, is nothing but phi, endlessly echoing through its derivatives and their dimensional shadows. All of existence is the infinite echo of one field. Today, we listen to just one of those echoes. In the previous part, we met d phi, the unified change of phi along paths that mix time and space. We saw that reality does not speak in separate time words and space words, but in spacetime sentences written by d phi. Now, in this part, we pick up exactly where we left off and ask one of the most beautiful questions you can ask inside that sentence. If phi is drawing a moving pattern through spacetime, how fast must I move to stay with it? To answer that, we meet v as propagation meaning. I want you to imagine that we are standing together on a long beach, looking out at the open ocean. Far from being just a picture, the surface of the water is one huge page on which phi is writing moving patterns. Some waves rise and fall close to us, others roll slowly from far away. And beneath everything, there is a deeper rhythm we cannot fully see. You pick one particular crest, one bright line of foam, and you decide, I want to stay with that one. In that moment, you are quietly asking the holophase question of this part. What kind of motion keeps me loyal to that pattern? The surfer's wisdom is the most direct doorway into V. Forget formulas for a moment and step into the body. You are on a surfboard, just outside where the waves are breaking. A wave is approaching from behind. If you sit still, the crest will lift you briefly and then rush ahead, leaving you behind. If you panic and paddle too fast, you will shoot down the front and the crest will fall behind you. Only when you match a very particular speed and direction does a kind of magic happen. The wave and you lock together. You look down, and the same part of the water seems to stay under your board. The crest does not pass you, and you do not pass the crest. You have tuned your motion to the wave's phase. That tuned motion is the heart of V. In the holophase language, V is not how fast something moves in a loose, everyday sense. V is the answer to a very precise question. How fast and in what direction must I move through space per unit of time so that I stay on the same phase of phi? It is motion defined by phase loyalty. It is the speed of staying with the pattern. We can say this in three complementary ways. In time language, V answers, how much space must I cross during each tick of my clock if I want the phase of phi to look unchanged? In space language, V answers, how much time must pass for each step in space if I want to land again and again on the same crest of the pattern? In motion language, V is the instruction that ties those two together into one concrete rule for moving. This already makes V different from the everyday velocity of a car on a highway. When we say a car is traveling at 60 miles per hour, we are comparing its position to fixed roadside markers. V is subtler. It compares your motion to the internal rhythm and texture of phi itself. Two people could be moving at the same ordinary speed, but only one of them might be following the V that keeps them on a specific phase feature. One is simply moving, the other is surfing a particular sentence of reality. Because V is about alignment with pattern, it immediately has a dimensional echo. In the time echo, V shows up as how quickly phases pass you when you do not match the crest exactly. If V is large and you stand still, crests crash by you quickly. If V is small, they drift past slowly. In the space echo, V shapes how widely spaced those crests must be for a given rhythm of oscillation. If the temporal ticking is fixed, changing V stretches or squeezes the pattern in space. In the motion echo, V is simply the flow itself, the concrete path and speed of the pattern as it travels. To understand V more deeply, we need to remember its parents, omega and k. Omega is the temporal voice of phi, the local ticking rate at each point. K is the spatial voice, the local sharpness of variation across space. On the holophase tree, these are the first two big branches above the root. V does not sit beside them as a third independent branch. V is born from their relationship. Think of omega and k as dance partners. Omega brings the beat, fast or slow, smooth or stuttering. K brings the choreography, tightly curled steps or long sweeping arcs. If they stand apart, there is no dance. The dance only becomes real when the beat and the pattern move together. That combined movement is V. V is what you get when temporal rhythm and spatial texture agree on a way to move through the world. In the language of DeFi, this relationship becomes vivid. In the last part, we picture spacetime as a grid of events, each with its own value of phi. DeFi told us how phi changes when we move a little in time and space together along some small path. Now imagine asking a special question of that total change. Can I walk through this grid in such a way that as I move, the value of phi I see stays the same? In other words, can I choose my motion so that dphi along my path is as close to zero as possible? When such a path exists, its velocity is exactly v. V is the motion that makes dphi vanish along the journey. You do not need to see the equations to feel this. Return to our ocean. The wave has some temporal rhythm. Crests pass each fixed point on the water at a certain rate, that is, omega. It also has some spatial pattern. The distance from crest to crest gives us k. If you know both, you can immediately infer the speed at which the crests move along the surface. That speed is v. Change the rhythm while keeping the spacing the same, and the speed must change. Change the spacing while keeping the rhythm the same, and the speed must change again. V is nothing mysterious. It is just a consistent way that time rhythm and space spacing combine into motion. This is not unique to water. In a vibrating string, if I tell you how many times it oscillates per second and how long one wave cycle is along the string, you can tell me how fast the pattern moves. In light, if I tell you its color, which is its omega, and how tightly its wavefronts are packed in a given material, which affects k, you can determine how fast that color of light propagates. In sound, the speed of a musical note depends on both its pitch and the properties of the air it travels through. Everywhere, V emerges from the dance between omega and k. Now we come to one of the most important refinements in this story. When we talk about how waves move, there are actually two distinct kinds of motion. Both are part of V, but they answer different questions. The first kind is phase speed. This is the surfer's motion. It asks, how fast does a specific point of constant phase move? Imagine painting a bright red dot on the crest of a wave and watching how fast that dot travels. That is phase speed. With marching soldiers, it is the speed of the marching line if you follow the moment when each boot strikes the ground in the same part of the step. The second kind is group speed. This is the motion of meaning itself. Imagine not one endless wave, but a localized packet, a splash, a pulse of light, a short whistle. Inside that packet, many individual wave cycles live together. Their phases may move quickly, but the packet as a whole has its own slower, broader movement. Group speed answers: how fast does the overall packet of energy and information travel? You can picture this in a stadium. When the crowd does the stadium wave, the people are the particles. The standing up and sitting down motion is the phase, and the wave of raised arms that circles the stadium is the group. The vertical motion of each person has its own rhythm, but the wavefront of raised arms moves at its own speed around the circle. That speed is group speed. Something similar happens in an ocean storm. Individual waves may rush quickly beneath a small boat, but the broader storm swell, the region of rough water, moves more slowly across the sea. That region is a group, with its own group speed. In the Holophase language, both kinds of motion are aspects of V. Phase speed is V as seen by locking onto a particular phase point. Group speed is V as seen by watching how a structured envelope of many phases moves as a whole. Why can they differ? Because they answer different questions about the same underlying phi pattern. If the relationship between omega and k is simple and linear, these two speeds coincide. But if that relationship is curved or more complex, the speeds separate. That separation is the root of dispersion, of pulse spreading, of color-dependent bending, of many subtle phenomena in wave physics. If you want to see the precise mathematical distinction between phase speed and group speed in the holophase framework, you can search for holophase on Zenodo. There you will find the scientific papers where these ideas are written in full mathematical detail. What we are doing here is giving you the story version, the conceptual literacy, so that when you do look at those formulas, they will already feel familiar. Let us now place V within the master tree of phi and its derivatives. In Book 2 of this episode, we are exploring the first order alphabet. Phi as the silent root, omega as temporal meaning, k as spatial meaning, d phi as unified spacetime change, and now V as propagation meaning. Phi is the blank page and background hum. Omega and k are the first descriptive letters for time and space. D phi is the first true spacetime word. V is the first action verb. On the tree, we can imagine a temporal tower rising from omega, a spatial tower rising from k, and a mixed branch emerging from d phi. V grows right at the junction where these begin to interact. It is not a new trunk, it is the first major bridge. When you ask d phi to vanish along a path, you are essentially asking, what motion would make my experience of phi as simple as possible? The answer, encoded in V, is move like this and the phase will stay the same. In this sense, V is the rule the language gives you when you ask for the simplest possible narration of change. Because V is built from omega and k, its dimensional echoes are especially rich. In time, V shows up in the rhythm with which patterns arrive at a fixed location. If V is large, many crests pass each second. If V is small, the arrivals are slow and stretched out. Suppose you stand beside a railway track and watch a repeating pattern painted on the side of a train. Red stripe, blue stripe. Red stripe, blue stripe. The speed of the train controls how quickly that pattern scrolls past your eyes. That scrolling rate is a time echo of V. In space, V shapes the spacing of patterns for a given temporal tempo. If a string vibrates at a fixed omega, but the medium allows faster propagation, The crests must be farther apart, and the pattern stretches. If the medium slows propagation, the crests bunch together. In a sunflower field turning toward the sun, you may see a wave of turning pass across the field. The distance between rows that have already turned and those that have not yet turned encodes a spatial echo of v. In motion itself, v is the flow phase. Picture lines painted on a conveyor belt. The belt speed is v. The lines do not move relative to the belt, they ride it. Phase features in a wave are like those lines, and v is the speed and direction of the belt that carries them. As the belt bends around rollers or passes over uneven ground, v changes direction or magnitude in response to deeper structure like curvature and forces which belong to higher branches of the tree. But at this first-order level, v is the clean statement. This is how the pattern travels. To feel v in everyday life, you do not need an ocean or a laser. Walk with a friend. Your friend has a natural walking rhythm. That is like their personal omega. Their stride length, how far they move with each step, plays a role like k. To stay beside them, you must choose a certain speed. That speed is your v relative to their personal pattern. If they speed up the rhythm or lengthen their stride, you must change your v to keep phase with them. Or think of traffic on a busy highway. The average spacing between cars is like a spatial pattern. The rate at which drivers respond and adjust is like a temporal rhythm. From these, a characteristic wave speed emerges. The speed at which holes and dense regions in the traffic move along the road. Sometimes a phantom jam moves backward relative to the cars. Drivers slow down and then accelerate even though there is no obstacle. That backward moving wave has its own v, quite different from the speed of any individual car. When you find yourself stuck such that the same bunching pattern stays around you for a long time, you have unconsciously matched your v to the v of that traffic wave. These analogies all share the same structure. There is a repeating pattern in space and time. There is a particular motion that keeps you aligned with that pattern. And there are other motions that let the pattern pass you by, or that make you race through it. In every case, you can ask, what is the v of this pattern? The answer is the same kind of answer the holophase language gives, the motion that maintains phase coherence. Because v is about motion, it is also one of the most directly testable parts of the holophase framework. Every time we measure how fast a wave travels, we are checking a prediction about v. The holophase model does not just say there is some v, it says exactly how v should depend on the temporal and spatial properties of phi in a given medium. In practice, that means if we can measure omega and k, we can predict v. Then we can measure v and see whether reality agrees. This leads to clear falsifiability. In a simple medium like air at a fixed temperature, measuring the speed of sound for different pitches tests whether the predicted relationship between omega, k, and v holds. In optics, measuring how different colors of light slow down and bend in glass tests another branch of the same structure. In water, watching ripples of different sizes move with different speeds on a lake surface checks yet another instance. If the measured propagation speeds systematically disagree with the v inferred from omega and k, the holophase semantics of v would need to be revised or abandoned. We can also design more subtle tests. In interference experiments, such as the classic double-slit setup, electrons or photons produce patterns of bright and dark regions on a screen. Those patterns arise because different possible paths have different phase accumulations, which depend on how v behaves along each path. If the pattern shifts in ways that contradict the predicted phase-preserving paths, our understanding of v would be in trouble. In gravitational lensing, light traveling near a massive object appears to follow curved trajectories. In the holophase picture, those trajectories are paths along which d phi stays constant in a curved environment, and the bending reflects how v changes direction in response to curvature. Observations of such effects become tests of how v couples to deeper structure. All of this reinforces a simple but powerful point. V is not a poetic word for flow. It is a precise, measurable instruction that reality seems to obey. Given this temporal rhythm and this spatial pattern, move like this if you want to preserve phase. That instruction can be checked numerically, experimentally, and observationally across many systems. The detailed derivations, including explicit dispersion relations and propagation laws, live in the Holophase papers on Zenodo. Our purpose here is to give you the inner picture so that those technical details will have a clear place in your understanding. Before we finish, I want to walk with you once more around V, this time from several angles at once, so that it becomes not just an idea you heard, but a letter you can actually use in the language of reality. First, its linguistic role. In our growing vocabulary, phi is the substrate, the page, and the ink. Omega and K are descriptive letters, telling us how fast in time and how finely drawn in space. D phi is a whole word, combining time and space into one sentence of variation. V joins this family as the simplest action verb. Whenever the universe wants to say, this pattern goes there in this way, it conjugates that movement through V. V is not a decoration. It is the grammatical move that turns description into narrative. Second, its scientific essence. Operationally, V tells us how quickly a recognizable feature of a pattern moves. Choose any feature you can track. A wave crest on water, a bright spot of light, a region of high pressure in air, a coherent packet of neural activity in the brain. Mark it in your mind and ask, where is it now? And where is it a little later? The ratio between how far it traveled and how much time passed is your measurement of V. The holophase claim is that this V is not arbitrary. It is determined by how phi is differentiating in time and space underneath that feature, by omega and k. Third, its dimensional expression. The same V shows itself differently depending on which dimension you pay attention to. In time, it appears as the rhythm of arrivals, how often the pattern passes a given place. In space, it appears as the spacing of structure for a given tempo. In motion, it appears as the trajectory that a feature traces through spacetime. These are not three different quantities, but three shadows of the same underlying propagation meaning. If you understand one of them deeply, you can infer the others. Fourth, its relations to neighboring branches. V cannot exist without omega and k. They are the parents whose relationship it encodes. V also cannot be fully understood without d phi, which provides the spacetime stage on which V is defined as the path of nearly constant phase. Above V, in the next book of our journey, lie alpha and the spatial acceleration structures. These describe how V itself changes. In that sense, V is the bridge between the first-order alphabet and the second-order nuance block. It is the lowest rung of the motion ladder, the place where straight, steady propagation lives before curvature and forces complicate the story. Fifth, stability and variability. Some patterns have almost perfectly constant V. Light in empty space is the most famous example. Its V is the same for all observers who move in straight lines at constant speeds. That stability is what allows us to define clocks and rulers in a consistent way. Other patterns have V that changes gently, like waves that slow down in shallow water, or sound waves that travel differently in warm and cold air. And some patterns have wildly varying V, like shock waves in a turbulent fluid. In each case, we can ask, is V stable here, slowly drifting, or rapidly changing? The answer tells us whether we are in a regime where first derivatives dominate or where second and higher derivatives are shouting more loudly. Sixth, falsifiability. V makes strong, testable predictions. If we know how omega depends on k in a particular medium, we know how both phase speed and group speed should behave. We can measure these by sending pulses, tracking crests, and recording arrival times over different distances. If the measured speeds fit the predicted family of V-curves, the holophase reading of that medium gains support. If they do not, we must ask whether our description of phi, or of its derivatives, or of the medium structure, is incomplete or wrong. In this way, V is not just a poetic story. It is an invitation to numerical confrontation with the world. This is enough for now. As we close this part, let us zoom out again to see where we stand in the larger journey. Episode 7 is about becoming literate in the full holophase language. In the first book, we stepped back to see the whole tree, and we understood why this is a true language rather than a narrow code. In the second book, we are meeting the core alphabet. Phi gave us the silent background. Omega and K gave us time and space as structured meanings. D phi showed us that reality writes in spacetime sentences, not in separate time and space words. Now, V has shown us that motion is not an extra ingredient sprinkled on top of this picture. Motion is what you get when the temporal and spatial meanings of phi decide how to move together. So hold two images from this part. One is the surfer, feeling with their whole body the delicate balance between falling behind the crest and racing ahead of it, and discovering the one specific speed that keeps them perfectly on the wave. The other is the master tree, where V hangs as the bright first branch of propagation semantics, connecting the time tower and the space tower, and carrying patterns outward into the world. Whenever you see a pattern move, whether it is a shadow sliding across a wall, a line of birds crossing the sky, or a pulse of sound in a concert hall, you can quietly ask yourself, what V is this pattern expressing? What motion keeps it coherent? When you ask that, you are no longer just watching events. You are beginning to read the propagation verb in the language of reality. In the next part, we will step from pure motion into the change of motion. We will meet alpha, the way tempo itself bends and curves, and begin to see how forces and accelerations arise naturally from higher branches of the same tree. But for now, let V settle in you as the feeling of moving just right to stay with a pattern. That feeling is one of the universe's simplest sentences, spoken in holophase. Salam, and peace be upon you, until we meet again in the next part.